Here's a method for graphing a transformed sine or cosine function. We've got all the different parameters a, b, c, and d for the standard kinds of transformations, either of a sine or a cosine function. And I'm going to illustrate in this example. It won't have all the complexity, but I have another example that illustrates a few other things that can happen. You should watch that after this. So first, we assemble some crucial data about the function. There's some crucial parameters or descriptive numbers about the function that are going to be useful. The period is a good one to start with. We have a master formula for that. It's 2 pi over b. Let me put p equals. And so in our example, it's going to be just 2 pi. That's one of the things that's rather simple about this one is I decided not to put a b in here. Okay. So quarter period, what we found is that when we plot these things, there's these crucial points that happen 4 times every period. So every 1/4 of a period, we step along and we find either a center line point or a max or a min, and so that's going to be pi over 2. So that's going to be crucial for stepping through. Then the amplitude, that's how big it is. Remember, it's not top to bottom, it's top to middle, and it's the absolute value of a is just equal to 2. I decided not to put a minus sign in. That's another thing that goes into the other example. And what about the center line? I just mentioned the center line. One thing that's really important is the amplitude here is the distance from max or the min to the center, not to just the x-axis. Okay, so that's really important. It's how big it is around its own center line, and if there's a shift, like with this one, that's not going to be how far it is from the x-axis. So the center line, that's very easy. That's just the vertical shift, and that's equal to 1. So let's say y equals 1. It's really a line. That's because cosine and sine, their center line naturally is the x-axis, y equals 0, and so you can just read that off. So this is the most complicated thing we've done so far, 2 pi over b. And then the other ones, you just read this off without a minus sign. You just read this off. Now, there's a couple of other things that are really useful, which are the max and the min. The max of this function is just, here's the center line. How far does it go from the center line up? 2. It's just the sum of these two numbers. So 2 plus 1 equals 3. And the min is minus 2. That's the amplitude is also how far it goes down. Plus 1 equals minus 1. Okay. So the great thing about that is that these three numbers, 1, 3, and minus 1, are the only y values we're going to need to plot. Okay, and then the last thing is, where's the anchor point? That's what I call the start of sort of the fundamental cycle. It's if we think of this as a standard sine function shifted around, it's where the origin ends up. So for a sine function, the sine goes through the origin here, and if I shift it right or left, up and down, it's that point is going to end up somewhere else, and that's the anchor point. For a cosine function, it's a little different. There, the anchor point is still x equals 0, but would be y equals 1, and then that gets shifted. That's in the other example. Okay, so how do you find the anchor point? Here it is. What we're trying to do is we're trying to make the sine function think that it's just at its starting point. We're just trying to figure out what should I put in for x so that this whole quantity is equal to 0. Okay, and so that's really crucial. Let me put here, solve bx plus c equals 0. And so in other words, here we're going to just take x minus pi over 4 equals 0, and so x equals pi over 4. There might be a little bit more work here if there's a b, but it's really not too bad. Okay. Now there's a terminology, a little more official terminology. That's my terminology. The x-coordinate of the anchor point, this start of the cycle position, is called the phase shift. Okay. The book and many books have you memorize a formula for the phase shift, but it's pretty tricky because it depends on exactly how this is written. I just say solve whatever's inside the parentheses, inside sine or cosine, equal to 0. That's all you have to do. It's always going to give you the right answer, no matter how this is written. Solve whatever's inside the parentheses, however it's written, equal to 0, and find the x. Okay, and then let's go ahead and find both coordinates of the anchor point. It's pi over 4, and what is the y coordinate? Well, remember the point was that this is the magic x so that this has become 0. So this is whatever sine of 0 is, so that's 0. For cosine, it's a little trickier because it's 1. Here, for a sine function, this all dies, and we just get the midpoint. That makes sense, because what is a sine function supposed to do? As it's going through its start of the cycle, it starts in the middle. Unlike cosine, which starts high, the sine starts on its midline. Okay, so that's not a surprise that that's the same value as this guy. Okay, so now we're almost ready. We just make a little table. It's not a very big table. Let's actually make this kind of table here. That's good enough. Okay, and we just put in x and y. I don't know why I didn't make that math mode. Okay, so we just put in the anchor to start with and the value there. We put in, okay, now here's where we use the quarter period. You wonder why was he doing that? Because we're going to step up by quarter periods. Oop, I put in 2 fractions there. Okay. And what's going to happen? Well, it's a sine function. So it starts middle and goes high. Now, if this were a negative, that would be tricky because it would flip upside down. So you do have to pay attention to the sign here. That's where that matters. But it's not flipped upside down because there's no negative here. And so it just goes up to that midline value, which was, sorry, to the high value, the max value, which is 3. No further calculation required. Now step up. Oh, sorry. That was not good. This is pi over 4 plus pi over 2. What's pi over 4 plus pi over 2? It's 3 pi over 4. Okay, hopefully you caught that. It's like, what the heck? We're not just going to pi over 2. We're stepping by pi over 2. So we're adding pi over 2 each time. So that's adding 2 pi over 4. So here it's 5 pi over 4. Back to the middle value. Now 7 pi over 4. Down to the low value, which was minus 1. That was what we found out here. And then back 9 pi over 4. Back to the middle, which was 1. We could go on easily to produce another period, but let's go ahead and graph this. Looks like we have to go out to, let's see, 9. Let's just do it in steps of pi over 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is pi over 4. Let's say this is minus 1. Here's 1. Oops, it's kind of big. Actually, let's just say that that's 2, 1, minus 1, minus 2. And we need 3. Okay, and we just plot the points. Pi over 4, comma. Oh, what's really helpful, before you even start plotting the points, once you get the center line, I forgot about this. Once you get the center line and the max and min, you can go ahead and start putting some stuff in. You'll get a sense of the vertical scale that way, and you can start putting in these dotted lines for as far as that goes up, as far as it goes down in the center. And now we can just do it. We got pi over 4, comma 1. 3 pi over 4. Notice it's not the next one because the quarter period is pi over 2. So that goes to 3 pi over 4, if you can read that. And then to 5 pi over 4, so skip one of the grid points. And then 7 pi over 4, and then 9 pi over 4. And there's 1 period. If you want to continue, just keep stepping every other grid mark in this grid. Or step backwards and still do this pattern of middle, high, middle, low, middle, high, middle, low, etc. And there's our sketch graph.